Right. So in our CCNA, what we learned is this EIGRP is an advanced distance vector protocol. You see, I was telling you, sometimes CCNA people will say EIGRP is a hybrid protocol, but it is not at all a hybrid protocol. You should not call it as hybrid protocol. The reason is no way it is like link state. See, what is hybrid? Mixture of two. When advanced distance vector protocol and the link state protocol, when these two behavior combined, then only you can call it as hybrid.
Hybrid.
But there is no such thing you will see in EIGRP. You don't have in EIGRP any trace of link state, any trace of link state. You cannot see any trace of link state. You got it? What I'm saying? There
Link
is
state means.
OSPF, ISIS. It's coming later. You know, I just told you EIGRP, if you call it as a hybrid protocol, then it should have the characteristics of distance vector and the characteristics of link state.
Link state, yeah.
You really don't have this. Then you cannot call it as hybrid. What you have is some advancement to the distance vector. So if someone calls EIGRP as a hybrid protocol, which means they got only CCNA level knowledge. They're not really gone deep into CCNP kind of understanding. They really do not know the difference between distance vector and link state. Okay, so when we go to link state, you will understand how link state is different from distance vector. Let's not get into that now. Let's focus on today's topic called EIGRP, Enhanced Interior Gateway Routing Protocol. So this is an advanced distance vector protocol. And now this protocol is fast in convergence, meaning if there is any change in the network, the change will be immediately notified to in RIP. If you notice, when update stops coming, to remove those routes from the routing table, it took 240 seconds, isn't it?
Yeah.
It took 240 seconds. How many minutes then? 4 minutes.
4 minutes.
Is it fast convergence? No. What is convergence? Adapting to the change.
Yes.
Yeah. So EIGRP is immediate. Immediately everyone will know that there is a change and it will start searching for another alternate path. See, as long as the router keeps the old route, it cannot find the new route. It has to first throw the old bad route so that algorithm can find the better route, the next better route. I told you there is an algorithm called dual.
Dual, yes.
So if dual needs to find a path, there should not be any other path in the routing table. If there is a path already, it cannot find. So the old path need to be removed, the damaged path need to be removed, that is removed by triggered update. So updates are sent immediately as a partial update, meaning whatever the change that has happened, that change is flashed, not flashed, flashed to everyone. So everyone gets converged to the new changes. Everyone tries to throw those old routes and find the other alternate path. Now, this EIGRP supports, I told you, discontiguous network. What does that mean? If you have variable length subnet mask, what is variable length subnet mask? We got different slash. You see here, for example, /16. Here it is /24. Yeah, this is variable length subnet mask and discontiguous subnet because it's a classless routing protocol. EIGRP is a classless routing protocol. And now EIGRP supports multiple network layer protocol. What it means? What it means, network layer protocol. You know, in OSI, there is a layer called network layer. Do you remember the layer number?
L3.
Exactly. Layer 3 protocol, what are they? It says EIGRP supports multiple network layer protocol. What
It's a
protocol is working in layer 3? IP.
IP,
So when they say multiple network layer protocol, not just IP,
IPv6.
IPv6, not just IPv6, there are a few other protocols which we have never used called AppleTalk.
Mm-hmm.
And then Novel Network.
Mm-hmm.
So EIGRP supports multiple network layer protocol, meaning, I want to repeat again this point, for each layer 3 protocol, there is a special design needed, and EIGRP is designed. EIGRP is designed to be a routing protocol in IP, IPv6, AppleTalk, Novel Network.
Mm-hmm.
So it can work in all this environment.
Yes.
So if I have IP version of EIGRP,
Mm-hmm.
it doesn't mean that I have IP version 6 EIGRP. Why? This is different module. This is different module.
Mm-hmm.
They are independent of each other.
Mm-hmm.
For IP version 6, there's a separate EIGRP. For IP, there's a separate EIGRP. Likewise, AppleTalk, there's a separate EIGRP.
Yeah.
That is what it means. Here you have multiple network layer protocol support. Next, flexible network design. You see, if your network is too big, it is very difficult to handle.
Mm-hmm.
When you go to some big famous schools, you will see lot of admissions. So in one class, they cannot accommodate all the students. If they accommodate, it will be difficult to manage. The teacher cannot manage
Mm-hmm.
all of them. So what they do is they make more
Mm-hmm.
classes. Section A, Section B, Section D. They make more classes so that it will be easy to
Mm-hmm.
handle. You got that
Mm-hmm.
flexibility. Instead of keeping everyone in one class, when you divide them in multiple classes, you can focus on the student very well. You can teach them very well,
Mm-hmm.
and the performance of the school will grow
Mm-hmm.
higher.
Yeah.
School performance will get improved. Likewise, instead of we keeping the big network, we can make small group of
Mm-hmm.
autonomous system. Each group is one autonomous
Yeah.
system. All are running EIGRP, but not same
Mm-hmm.
EIGRP. All right, this is one
Mm-hmm.
group. This is another group. You want to handle your big network in 4 small groups so that it will be more effective
Mm-hmm.
management. So you got groups, you got groups to manage the network easily, which is possible in
Mm-hmm.
EIGRP.
Yeah.
According to your need, you can design the network. It is
Mm-hmm.
flexible. So I can say this is autonomous system 100, this is autonomous system 200, autonomous system 300, for autonomous system 400. So they're all
Independent. Mm-hmm.
in different groups. All right. But if you try pinging from A to B, the ping will not happen because they all belong to different autonomous system. But the
Mm-hmm.
protocol is same. See, your company do not want A and B to
Mm-hmm.
ping. They are all in same company's
Mm-hmm.
network, but according to the company, they want to handle all these network members separate. This one separate, and this one separate.
Yeah.
They want them to
Mm-hmm.
be separate, which is possible in
Mm-hmm.
EIGRP. See, you don't need to go for different protocol to achieve this. You don't need to have RIP here, EIGRP here, again RIP here. You don't need to do like that. You can have the same routing protocol with multiple groups. As you said, each group are independent of each other.
Sir, why you are going
Next.
with this
Yeah,
autonomous system? Because for granularity of the bigger network to smaller.
correct. It helps to group into small group. Like you have 10th
Mm,
standard A section, 10th standard B section, 10th standard C, A, B, C, and all
mm,
what? Groups. But basically, they are
mm,
all 10th standard. Likewise, this is entirely one big network, one office, one enterprises, one company. But in the company, they don't want this project people to mingle
yeah.
with other project people. They want to
Mm,
keep them separate. So this project is separate department,
mm,
separate. Like if you take
mm,
a college, if you take an autonomous college, you'll have a
mm,
lot of departments. There will be a cultural program conducted by computer
mm,
science department. There will be again cultural program conducted by
mm,
arts and science. There will be another by
mm,
physics department, chemistry. They're all totally different, but they all belong
yeah.
to one college, isn't it? Likewise, in a big network also, in an enterprises, we will have different groups. You want to have one protocol EIGRP, but you want to handle them separate. EIGRP supports that design. EIGRP supports that design. We call this flexible
Mhm.
network design. So you don't need to run for another protocol to have different groups. Same protocol can be deployed in
Mhm.
multiple groups.
Yeah.
Shall we go to the next point? Now, EIGRP don't like broadcast. You know how bad is broadcast? Broadcast is what? Sending to
Mhm.
anyone. So you remember
Yes.
version 1 RIP will
Yes.
use broadcast. When you broadcast, what happens is not only the RIP running router receives your broadcast, even the other routers and other computers,
Mhm.
printers,
Mhm.
everyone will receive it. Sometimes that will open ways,
Mhm.
doors for
Yes.
attackers to enter because you are
Yes.
broadcasting. Everyone who can, anyone can receive it. You're giving permission saying for anyone this packet,
Mhm.
this update. So RIP when it sends a packet saying this is for anyone, then even that anyone, one among anyone will be
Mhm.
an attacker also. So
In
this is
RIP
not
actually
good.
broadcast status means like 255 or 255. Yeah. All two.
255, 255, all 255, all 425. So EIGRP don't support. Instead, it will use multicast in order to talk to, if it wants to talk to every
Mhm.
EIGRP router, it will use multicast. If it wants to talk to one EIGRP neighbor, it will
Unicast.
use unicast. Please understand, it
Mhm.
can do unicast. RIP version 2 cannot do unicast. RIP version 2 can only do
Multicast.
multicast. Why? Because RIP never
Neighbors.
learns neighbor, never learns adjacent neighbor. But EIGRP, by sending hello
Mhm.
packets, hello is a small
Mhm.
packet. It is going to send the hello packet every 5 seconds. Every 5 seconds, EIGRP send the hello packet. See, this is okay. Sending hello packet 5 seconds is okay.
Mhm.
RIP is sending the entire routing table
30
every
seconds.
30 seconds. That is bad. Even though that is every 30 seconds, that is bad only because every 30 seconds, even when there is
Mhm.
no change, the complete routing table is shared. Complete routing table sharing takes a lot of processor bandwidth. and all the receiving routers also need to process. Even though there is no change, they process it. But EIGRP is not like that. EIGRP will send only hello packet first. It won't send anything like I have this network, I have this network. It won't send any routing table in the first place. First, initially it won't send like that. It will say hello only. If two routers say hello, and if the parameters in the hellos are acceptable, see if someone is saying hello to me, I will not immediately talk to him nicely because I want to see whether he's coming with a good motivation, motto or bad mottos. So I'll wait. I'll listen to his words, his body language, and when the parameters matches with me, if I find him as okay, this guy is not a harmful guy, then only I talk to anyone freely. You know, whenever I meet someone in some airports, I talk to them freely in my beginning days, thinking that all those people who come to the airport is decent guys. So once it happened in China, I got I need to wait for the whole night and whole day in the airport. Not only me, like me, many passengers, around 300 passengers. No. Around thousands of passengers. Because there was some war between Hong Kong
Okay.
and China. So we were not allowed to fly from Shanghai to
Okay.
Malaysia via Hong Kong. So all the
Mhm.
flights were cancelled. I was talking everything to that man. But anyway, he's not a bad man. He was
Mhm.
from Dubai. So what I'm trying to
Yeah.
say here is EIGRP is not like that. EIGRP is very
Mhm.
careful. It will send the hello packets, and there are some parameters that should match with
Mhm.
two routers to form
Mhm.
neighbor. One of the parameter is both the router need to be same autonomous
Yeah.
system number, from same autonomous
Number.
system number. Secondly, they both need to have same
Mhm.
subnet. You know, if two routers want to
Mhm.
form neighbor, if this is in 20.0.0.1, if this is in 30.0.0.1,
No.
will they
Mhm.
form neighbor? No. No, must match. The subnet should match. This also should be 20 dot something
Mhm.
like 2 or something. And this also should be autonomous system 10. This also should be autonomous
Mhm.
system
Mhm.
10. So it will check for a few parameters. If authentication is enabled, it will also check whether the authentication
Mhm.
matches. After checking all those things, only after checking all those
They form a neighbor.
things, they 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 agree to
Mhm.
form a neighbor. This all happens using
Yes.
multicasting. Once the neighbor is established, it starts sending updates to the neighbor in a
Mhm.
unicast way. Okay, it sends to the neighbor. If neighbor sends a query, it replies in
Mhm.
unicast. But sometime if there is an update for all the neighbors, it will use
Mhm.
multicast. It depends on what type of
Mhm.
update. Okay, so it never uses broadcast as a
Mhm.
good news. It uses multicast to send hello, and it also uses multicast whenever there is some update
Mhm.
common to everyone. See, multicasting is a very important topic,
Mhm. Okay. Yeah.
which we cover in CCNP in very deep. No multicasting is touched in
Mhm.
CCNA, but we learn multicasting here
Mhm.
very deep. It's very important. When we go there,
Okay.
you will understand. When we will explain later. Now EIGRP. Now next is EIGRP supports two type of authentication. Sorry, two type of summarization.
Mhm.
One is auto
Mhm.
summarization, or you can also say global summarization. Another one is manual summarization. See, global summarization is for the entire router, all the networks. You do summarization. So when you do global summarization, the summarized route will be sent to every neighbor.
In the same autonomous system,
I
right?
repeat.
Yeah.
Yeah, correct. In the autonomous system, when you do global summarization here, when you do global summarization or automatic summary, auto summarization, the summary route only will go to all these neighbors. But manual summarization is not like that. Manual summarization is summarizing for only one neighbor. You see, I do not want to send summary route to A and B. I don't want to send summary. I want to send detailed route information. But only for C, I want to send summary. So I can do on the interface a summarization, which is called as manual summarization. That is why they call it as any point. Wherever you want, it need not to be global. Any point, this point or this point or this point, wherever you want, you can enable manual summarization.
So manual
You got it?
summarization, I mean,
Manual
it will be
summarization is interface
okay.
level summarization. Manual summarization is interface level summarization. Auto summarization is global summarization. Global
Global
interface
summarization.
level.
So that will be like it's a brief kind of thing, right? And in interface level, it is
See, summarization, no. Summarization itself is
okay.
brief only. If you want to send that brief thing to everyone,
Okay.
you do globally. If you want to send to one particular neighbor only, then
Okay.
you do manual.
Got it.
Okay, next. As I said, EIGRP supports VLSM, discontinuous network, which means it's a classless routing protocol. See, when there is a classless routing protocol, there are chances of loop. If you don't do proper summarization, you see, if this also says I have 10, if this also says I have 10, if this also says I have 10 network, it's not saying 10.3.1, it is not saying 10.3.3, 10.3.2. If it is not saying properly, if summarization is wrongly done, then this router will think 10.3
Yeah.
is here. This router will think it is here. This router will think it is here. It is here.
Yeah.
It will be looping. Whenever there is a classless protocol, there are light chance of, see, only if someone makes a mistake, I'm telling you. In layer 3, there won't be any loop in first place. Layer 3, no loop. But if summarization is not properly done in a classless routing network, then loop will
Got
occur.
it.
Manual summarization at any point. You can do summarization at any point, that is true, but you need to be very sharp, very clear when you apply the summarization. I'll when we go to summarization, I'll make you very much clear,
Okay.
comfortable. So when you do proper summarization, EIGRP will guarantee you 100% loop free using the same algorithm called
Dual.
diffusing update algorithm. So the diffusing update algorithm is responsible for you to provide 100% class
Loop free.
free, sorry, a loop free classless routing. Not only that, it is the same protocol's responsibilities to pick the very best path. There may be many paths. Very best path. If you want very best path, you need dual algorithm. Diffusing update algorithm. Dual algorithm. So EIGRP is guaranteeing you 100%. 100%. Wow, wonderful. But again, I'm repeating. EIGRP is taking its steps to provide 100%. But summarization, if not properly done, EIGRP is not cannot guarantee you that. It's our mistake. Summarization is proper summarization is mandatory. Only then you can say my network is loop free. If summarization is not properly done, EIGRP will somehow manage to stop the loop, but the results won't be as per your expectation. Some routes will be missing in your routing table. EIGRP will still come and stop the loop, will guarantee the loop. But the routes that you are expecting, the ping that you are expecting, the reachability that you are expecting won't be seen. So 100% loop-free classless routing. Next is when you talk about EIGRP, there is no big difference when you configure this EIGRP in WAN and in LAN. The same commands that you use in LAN EIGRP, you will also use in WAN EIGRP. What is WAN? You know, WAN is this is your office, this is your branch office. You are connecting through an ISP.
Yeah.
This is what called as WAN. Here to here, you're going to have one virtual connection. This is what called as wide area network. Tunnel. So if you are running EIGRP on this tunnel, there is no special consideration needed actually. It's easy, same like what you do in LAN, it's same configuration for WAN also. Now, I was telling you the other day, EIGRP can even do unequal cost load balancing. There is equal cost load balancing seen in every protocol. Equal cost load balancing is seen in every protocol. What is equal cost? If the hop counts are same for a destination via multiple paths, they are called as equal cost paths. Those things are still available in all protocol. But the unequal cost load balancing is not supported in any other protocol except EIGRP. But again, I want to tell you, it is not by default, not enabled by. So here in CCNP, we will be doing this lab, how to enable this unequal cost load balancing. We use something called variance. We use something called variance to achieve this. Unequal cost load balancing is achieved using variance configuration. Right? So load balancing can be done across equal as well as unequal cost path. Sorry. Next. EIGRP's terminology. Neighbor discovery and recovery. Now, how a new neighbor is discovered? I told you by sending hello packets. Using multicasting. What is the address, you know? 224.0.0.10. Using this multicast address, the packet will be sent. Now, because the packet is going to this address, all EIGRP router will say, it's mine, it's mine. Because the address 224.0.0.10 is EIGRP. So all router which runs EIGRP will say, it's mine, let me open this packet. All will open the packet. All EIGRP will open the packet. So the hello packets are sent between neighbors using this 224.0.0.10 address.
5 seconds.
How often? 5 seconds. Every 5 seconds, the hello packets are sent.
Yes.
Using that only the neighbors are discovered. Now, after neighbor discovered, the neighbors will be maintained. How? By sending hello packets every 5 seconds and receiving hello packets every 5 seconds. See, after forming neighbor, it won't go quiet. It will keep sending hello to neighbor to make sure that I'm alive. Every router will send the hellos every 5 seconds to make sure other router
Yes.
to know that this router is still available. It is not dead. And not only that, if a neighbor is not saying hello for 15 seconds, the neighbor will be considered to be dead. And when the neighbor comes back, again the
Neighbor,
same
yeah.
hello packet will help to recover the neighbor. So the neighbor
Hello packet.
discovery and recovery is through hello packets.
Five.
How often it is sent? 5 and 15. Now, EIGRP when you enable, not only dual algorithm gets enabled, there is also another protocol called reliable transport protocol gets enabled. Reliable transport protocol gets enabled. Now, reliable transport protocol is for what? It is, as the word says, reliable. It is to guarantee that all the updates are delivered to all the EIGRP neighbors without missing. So there's a kind of there is a kind of acknowledgement when one router sends an update, the other router after receiving it will send an acknowledgement by using RTP. See, in networking world, RTP simply means real-time protocol. Real-time protocols are not this EIGRP RTP.
Okay.
Real-time protocol is actually a voice protocol. Okay, so should not get confused with it. Sometimes people will say RTP, RTP. Don't think that they are talking about EIGRP. In networking, RTP means only voice protocol. Okay, but EIGRP also uses the same term. It's a Cisco's protocol, EIGRP. This also says we have a protocol called RTP. That is enabled. You don't need to enable or disable this protocol. There is no option for you to configure this RTP actually. There is nothing to do with the dual algorithm RTP. You cannot do anything. They get enabled inbuilt. They are inbuilt in EIGRP. When you enable EIGRP, they all get enabled. And this is a kind of connection-oriented approach in a layer 3 level. See, we do have TCP,
Layer 4.
which is a layer, where layer 4. But this EIGRP is not working in layer 4, network layer protocol, isn't it? It's a layer 3 protocol. Then how do you guarantee with the help of this EIGRP's own guarantee mechanism called RTP? So EIGRP is a reliable protocol. You see, it is providing you the guarantee of updates, delivering system to all the neighbors. Not only that, as we already discussed, there is an algorithm to pick the best path for every destination to select the best path. Which one is the best path?
Yeah.
Low cost path is the best path, isn't it? Path with the low cost is the best path. So for each destination, low cost best path along with loop free is picked up by this algorithm called dual
Update algorithm.
diffusing update algorithm. Do we need to go and learn this algorithm? No. Do you have any way to look into this algorithm? No. Do you have any commands to do something with this dual algorithm? No. So we need to simply trust and go. That's all. Okay, EIGRP has got this algorithm. And that is the algorithm which is giving the guarantee. Sorry, which is picking the best low cost path, which is also loop free. That's all. But how it works, I'll be explaining you later. But you will not be able to see those things. What all? I think it's coming in the next slide or the following
Okay.
slide. No. After 2 slides, it's coming. Okay, that is a very important portion which many people do not know proper. Okay, next. This last point, PDM, we have already seen. Protocol dependent module, meaning for each layer 3 protocol, there is a separate
EIGRP. Yeah.
there's a separate EIGRP designed. So they're all independent of each other. So in a router, I can run on AppleTalk EIGRP, on IP EIGRP. In a
IP
router, I can run
EIGRP.
one IPv6
Okay.
EIGRP, another IPv4 EIGRP. So they are all independent of each other. IPv4 depends on its own module.
Yeah.
IPv6 depends on its own EIGRP module. IPv6 EIGRP module cannot be used by IPv4.
Yeah.
They are all
Yes.
independent of each other. Is this page clear? No. EIGRP maintains 3 tables. One, neighbor table. Neighbor table is a table where the established neighbors are maintained. The information about the established neighbor, not the neighbor configured, or not the neighbor which is in
Yeah.
negotiation. Established. One router sends hello to the other router. The other router has accepted the hello. The other router not only accepted the hello, accepted as a neighbor. Likewise, this router also accepted the hello, accepted the other guy as the neighbor. Such neighbors are stored in the neighbor table. So you will in the neighbor table you will see
Yeah.
the neighbor's router. Who is the neighbor? The next hop. Can R1 form neighbor with R8
Yeah.
without forming a neighbor with R2?
Yeah.
Not possible. Next hop is the neighbor. R1 cannot form neighbor directly with this even if it is physically connected. Not possible. First it has to form neighbor with this, and this has to form neighbor with this, and this has to form blah, blah, like that only. So that's why they call next hop router. Neighbors are always next hop routers for EIGR.
Remote.
Only for BGP,
Yes.
no, the neighbor can be remote. I repeat, only for
Remote
BGP,
means
the neighbor can be
not
remote.
the next door, maybe. Yeah.
Only for BGP. They can. They need not to be next hop. They can be even 10 hop away. Two routers can form neighbor even if they are very far. In between, they may have many routers. We'll talk about that when we go BGP. BGP is one another topic which we go really very, very deep
Yeah.
in CCNP. Now, let's go here. In neighbor table, you will see all neighbors interface via which you connect to the neighbor and the IP address of the neighbor. For example, now, if you check R1's neighbor table, let's say this is E0 and E1, it will say I got 10.1.0.2. He's a zeroth neighbor. Which neighbor? Zeroth neighbor via E0. And I got first neighbor called
E1.
10.2.0.2 via E1. You see? So this is what you will find in the neighbor table.
Yeah.
I'm just writing only few things. There are a few more things also you will see. What is that called? Round trip time. What is round trip time? For you to send the hello packet
Yeah.
and to get response.
Mm.
See this RTP, no? The RTP sends an update. It gets an acknowledgement, right? So the time taken is what called as a round trip time. How long it takes to talk and get the response from this guy, and how long it takes to get response from this
Understood.
guy. That is information will also be seen there. Right. So the neighbor table will have the list of directly connected routers that runs EIGRP with which the router has already formed adjacency, already formed a neighbor. Now, you see, this is the page that I was talking about. Many people are not comfortable with this dual algorithm. We saw a dual algorithm is responsible to pick
Without loop.
the low cost path for each destination and to guarantee loop free. Now, how it is doing that is what explained here. How it is done is what explained in this page. Right? Now, after going through this dual algorithm, the topology table will have for each destination the best path, which is called as successor.
Best path. Okay.
What is the meaning of successor? Best path. And the second best path is called as feasible successor. You see, feasible. So in the topology table for every destination, if there are multiple paths for every destination, then for every destination, you will have a successor route. If all the paths are of same cost, then you will have many successor because all will be best. If one is low cost, other one is high cost, then you will see successor route and second successor route, which is called feasible successor route. But to find out the best path and the second best path, we need to understand this very well. We are going to go in depth in this thing. This is very important page. So I'm just giving you background so that you will, when you come to this page, you will understand better. So
Yeah.
the neighbor table will have simply neighbors, but the topology table will have for each destination best path. If there is a second best path, see there may be some paths, but it may not be a second best path. If it is really a second best path, then you will see it as feasible successor because there is something called feasibility condition. The one which is there in the bracket is what called as the condition. Advertised distance of the feasible successor must be less than the feasible distance of the current successor route. Don't worry about that, and I'll be teaching you in detail later. So what I'm trying to say is EIGRP dual algorithm, EIGRP's dual algorithm has got that mechanism, that ability to pick the successor route and also the feasible successor route by checking some condition. Why it needs to check condition? Because the backup path should not cost loop. It needs to be a loop free. That is why you need to have this condition. I'm not going to explain this page in
Background.
detail today because this is very important. We'll keep it for another day. I'm just giving you a background. So topology table is not simply filled with some routes. There is a big criteria. There is a big selection process done by dual algorithm to pick the best low cost path, loop free path, as well as the best backup loop free path.
Yes.
So those things are in the topology table.
Yes.
In the routing
Routing.
table, you will have only the best path. Backup path will not be seen in the best path routing table. Only when you enable unequal cost load balancing,
Understood.
you will also see this one in the routing table. Otherwise, you will see only the success route. You see, only the best path is seen in the routing table. So EIGRP maintains three tables. One is neighbor table, which will have the list of neighbor and the connected interface and the next stop address of the neighbor. Topology table will have the successor route and the feasible successor route for every destination.
Diffusing.
For that, it uses algorithm called dual update algorithm. So what that mean is what explained in this whole page, which we will be seeing in our next class. And using that, you got the best successor route and feasible successor route. Successor route is what called as best route. Feasible successor route is called as backup best route. The best route alone will be put into the routing table. If this best route goes down, this will be promoted as successor and this will become the best route. It will come to the routing table. Now I want to remind you something. We learned EIGRP is fast in convergence. Now, did you understand how it is fast? Because it is maintaining the backup path. When the best path goes down, it can immediately promote that backup path as a best path.
Okay.
It no need to. No, much more less than that. Why it needs to get the update? It already have the information which one is the backup. Why it needs to wait for someone to tell an update? When a best path goes down, it will immediately be notified. So it will immediately pick the feasible successor as the successor and put it into the routing table. And the route that is there in the routing table only will be used for packet forwarding. Now you see, this is an example. For C to reach this network, you can go via A, you can go via B. In the topology table, you have both. Going via A, going via B. But only the low cost path is the best path. Going via A is only seen in the routing table. But what I have explained you only 50% in this diagram. What you understood is only 50%.
Okay.
The other 50% you will understand after we learn this one, right? So I would like to stop here because the